Recording. So, perfect. We're moving to third class today about information management. We will look at, as we've seen earlier, we have kind of this model of how is a data science project, right? We import data, we tidy it, we work with these parts, and then finally we communicate it. We started the first class just to look a little bit about the full picture, but we also looked at how specifically maybe to visualize the data, both in plots and in the second class a bit in tables, right? So these are the two ways we're thinking about visualizing data in this stage. Last week, we also looked a lot into transforming variables. So it might be that you work with data that the variables are not exactly how they should be. Sometimes when you start to do more statistical work, you might need to standardize the data. We calculated percentages. It might be that you have full time, but you want to find what is the ratio, what is the percentage of full time doing this, or you might have some kind of physical tests, for example, where we might need to, we get the full, so how much they lift. We're doing squats, for example, what's their 1 RM, but we want to have that divided by the weight of the athlete, for example. So all of these things we looked at last week. We looked a little bit, we mentioned how to save tables. So then we're in the communication part, right? How do we get out the results? Do we get different ways of looking at data? How can we get that into a format that we then can communicate with other people? Today, my idea is to just show you quickly also how to do the same with plots. So you're able to kind of save any figures, plots that you make. But the main focus this class is on how we tidy the data. And by tidy, we mean how do we get it into the format that we can then work with to transform, to visualize the data, and so forth. A basic tenet. So when we talk about tidy data, what we actually mean is that we have what is called rectangular data. And by rectangular data, we mean it looks like an Excel sheet, right? Where we have columns and rows. And it looks, so we don't have any weird shapes. It doesn't look like a triangle. We don't have a couple of values here and a couple of values there. So basically the thing, like, we organize our data into variables, which are our different columns. We organize our data into rows, which are each observation. And then each combination of the variable and observation is a value. So what do we mean by this? Our variables are what we are interested in looking at, right? So this might be, we need to know which athlete is it, which date did we have a training session, and then we might have some different measures during that training session. So what was the average heart rate might be one variable, right? What was the maximum heart rate during that session? How long was the session? These are different types of information about that particular training, right? So these are our different variables. Observations, so our rows, can vary a bit depending on what we actually want to analyze. Yeah. So when we talk about observations, and this is the same, you'll see more in statistics, probably you already did if you had some statistical course in your undergrads. We also sometimes call it a unit of analysis. So what is it that we're interested in looking at? This could be each athlete, right? I want to analyze how does nutrient intake relate to body mass, right? Does athletes with a higher nutrient intake have higher, lower weight, etc.? Stupid example, but you see the point. Then my unit of analysis, my observations are athletes, right? I observe one athlete, I write down a bunch of data about it, I go to the next athlete, da. But this might also be, for example, it might be that we have several measures of the same athlete. So it might be that we want to see how does this change over time within each athlete. Then our observations are no longer athlete, right? Our observations are athlete and measurement point, because each athlete might have several measurement points, which are each an individual observation, right? And so when we tidy the data, when we work with tidy or cleaning the data, we have to keep in mind what the final goal with our analysis is, because that kind of defines what counts as an observation. So should we have each training session of each athlete as a separate row, or might it be that we just have one cycling, one running, so we just have our observation is the athlete, and then we have different variables of interest. This might change even inside the same analysis, which means that sometimes we will have to work with changing data backwards and forwards. It might be sometimes it can be that for some analyses, let's say that we have 3 measurement points. So we might have like pre-season, middle of season, end of season, that we did some kind of physical test, some kind of measurements that we're interested in looking at. For one type of analysis, we might say that our unit of analysis is the athletes, right? We want to see, is there a difference between the athletes in their pre-season status, in their mid-season status, in their post-season status, right? Then our unit of analysis, our observations are, again, athletes. But it might be that we are interested in, okay, so how was the evolution from pre-season, in-season, post-season? And for example, if you remember how looked at ggplot a little bit, or we might want to summarize this data, then it might be that what we're actually interested in is not primarily comparing athletes between each other, but comparing the different time periods. So then we will need one row for each time point in athletes. This is a little bit sometimes a hard concept to grasp at first. Once you start kind of to work with data, if you just keep this in the back of your head, it tends to fall into place a little bit easier. But remember, again, what should one row be? And then the last part is that, so for each observation and variable, we have a value, right? So we make sure athlete is our first variable. Which is the athlete? Okay, do each observation have a name or an ID number for this athlete? Does the training date, each observation has a training date? Or as we saw last week, it might be that some of them are actually missing. that we're lacking information. It might be that we have different testing points. And for example, at one testing point, one athlete for some reason didn't complete 2 of the tests, right? Then for that observation, the value of that variable will be missing or inside our NA. So this is how we think of, this is what we mean when we talk about tidy data. So we want to get to here when we get new data. Today's data comes from the Golden Cheetah Open Data Project, which is by heart, it's a application, a free application, open software, where that's primarily for cyclists and triathletes to be able to analyze their race data or training data. So they go out, they train, they get the files from their power meters, from their heart rate monitors and so forth. They load it into this program, and you can do a bunch of analysis already directly within this program. So if you're you know that you will work with kind of cycling data, then you can just perhaps download this program and run it by itself. But part of this is that the people that use this application, they load in their data, they can choose to share this data anonymously. So what there is then is a huge repository of, I think it's about 120 gigabytes right now of data on a bunch of athletes, all their training sessions, and so forth. We will obviously not work with all this data, but the data comes from here originally. I've just prepared it a little bit to make it easier to work with. So that's where the data comes from. Today, what we'll do is we will look at 2 sets of functions. The first one is from a new package that we haven't worked with, that is also part of the Tidyverse, that is called tidyr, and which is focused primarily on getting the data into that rectangular tidy format. So we work with different ways of transforming, not transforming variables, but changing the shape of the data, basically. And then towards the end, we will also look a little bit into how do we combine when we have several different data sets. So in this case, we'll have data on different training sessions. So each training session, how was it, a little bit like that. And then we also have more information about the athlete. And this is pretty common when you do both work in practice and have some kind of research project, that you might collect some data on the subjects or the athletes, and then you have different data on the training sessions, then you might have different data on the tests, and at some point you will want to be able to start to combine these ones together. And these 2 parts are where I would say you really, really start to see the advantage of using a programming language like R or Python or Julia. There are several different ones that are more used in data science, in analytics. You can use any of them, but these things tend to get easier if you use a programming language than if you work in Excel. So for example, the first parts that we saw, and even calculating variables, can we create the percentage based on the totals and those things? You are actually able to do that fairly easy within Excel. And if it's really small things, that might actually just be easier to do it directly in Excel. The advantage is the reproducibility that we talked about the first week. So the ability to actually go back, redo the analysis, redo the transformations with the same data or with new data. But here, these parts are actually where Excel, SPSS, SAS, Stata, all these more point and click programs where they have a hard time actually working with how do we get the data into a correct format, into a tidy format. So we'll jump in. You have the link if you want to follow along. We will do startup the same way as always. We open our R. We create a new project. Let's see here. We will start a new project. Again, I save all of them in my projects folder here. That might vary. And we'll call it, or we give it a better name. We call it cycling training, for example. Okay, same as always, we need to get our data in here. So I normally go this way. I have here, I have the files in download. So we just take the files, drag them over, make sure we have them within the same folder as our project. I hope by now you start to see the pattern and remember these things. You should, I just got a question here. You should see the link to the data in the chat. Did any one of you manage to find it? Perfect. Great. Now, same again, we start with an R script, we save it, and here, one good practice when we work with these kind of projects is we might want to do several different kinds of analysis with the data, right? So it might be first we want to analyze average amount of training sessions per athlete, then we want to do some other kind of analysis. So you might want to save this in different files. So a good practice is every time you get data from outside that you need to somehow reshape, so tidy it into a nice format, is to make an R script, so one of the files that is separate and does only that. So we start to chunk up these things to not end up with one R script that is extremely long and hard to find in. And again, if we then want to redo another analysis, so we make a new R script, then we have to go through all the data tidying process again. So here, what we typically want to do is we have our raw data, we have an R script to clean the data, and we save our cleaned data, so we're able to use that for an analysis. So this R script typically tends to look similar. So I tend to try to give it the same name in all different projects I work with, just so I always find my way around. I always know that, okay, clean data is the first step where we get data from outside and I fix it into the format that I need. So we create this script. And for the first half today, we'll focus on this file, the training session file. We see that we still work with CSV files. So it's still the same way of importing the data that we've done previously. So first thing, we need to load packages. Sorry, let me get this one going as well. So we have, perfect. So you see my shortcuts. Here, what we need to do is we need to load a couple of packages. We could do as we did in the first class, and just load tidyverse, that we load a bunch of different ones. Today we go the other path. So we just load each of the separate packages that we'll need to work with. So the extra functions we need to do these things. So the first one was called readr, which is the one, like this, which is the one that we need to load the data, or read the data rather. And again, here we could separate. So we talk about raw data, which is kind of the data that we get, no matter the shape. And we have clean data, that is the data that we've fixed to the way that we want to work with it. And again, I try to be pretty specific with the terminology, and again, call them the same time always. So every time I go into a project, I know if I see raw data, I know what I talk about. I talk about the data that I haven't touched. Talk about clean data. This is the data that is ready to be analyzed. So again, just this comes back to the part of reproducibility, that is, can I redo the same thing in half a year? And the more consistent I am with terminology, the easier that gets. So we want to read the CSV file into assign it to an object that we call raw data. I tend to always call the first one, again, we import it, call it the raw data, which in this case is the training session. And here we see that we start to training sessions, and then it worked. Perfect. So again, things happen all the time. So just everyone gets errors all the time. The hard part is finding out what to do about them. So again, we have our raw data. We inspected a bit, 132 observations, 26 variables. If we just look ID, date, and then we have a bunch of peak, WPK, critical power. So, okay, if we look at the data a little bit more with a bit of context here. So again, going back to which type of data are we talking about? ID, we see that it's the same for a bunch of different rows here, and then it changed. So we could kind of suspect that this should be the athlete, right? Each user, each athlete have their own ID, so we can connect like all the training sessions of the same athlete together. Makes sense. Date, again, we know that these are training sessions, so date should be which date did they actually train. And then we have peak WPK, okay? In cycling, again, if you know a bit about cycling or know how you tend to train, this is watts per kilogram. Again, if I'm no expert in cycling, so from what when I looked at the data, when I checked it, it should be that here we have the peak watt per kilowatt of body weight generated. And then again, we have 1S, 5S, 10S, 15, 20, 30, and then we switch from S to M. So, okay, what could this be? Well, probably it's time, right? What is the peak VPK over 1 second of riding, over 5 seconds of riding, over et cetera, et cetera, et cetera. And that would make sense, right? Because if we think about it, during a short period of time, you should be able to generate more force, right? If I just have to cycle as hard as possible for 1 second, I could do that much harder than for an hour, 60 minutes. And we see the tendency seem to be, okay, 6, 7, 8 here. And if we scroll along, it seems to go down, right? Get lower and lower. So we can kind of just intuitively guess that here, the last part of these ones, we're talking about time. This is not the best way to do these things. The best way is to have that the one that gives you the data, or if you are the one working with the data, that you have a data dictionary, that you have a table saved somewhere that explains what all the different variables mean. This is how it should be. This is the good way to do it. Talking from practice, more often than not, this doesn't exist. Like, you get the data from a coach that you work with, you get the data from strength and conditioning. If you're into research, you get the data from another researcher that has their own way of naming things and doesn't really tell you, doesn't have everything written down. So being able to do kind of the detective work is an important part, even though it really shouldn't. We move on. Critical power. So critical power is a concept. How much power am I able to maintain over a certain period of time when I bicycle? So kind of, if I want to bicycle for 60 minutes, how much power can I generate? So how much force, how much power will I be able to generate and last for that long? So we see here, if we think about this, so we want to work with, we're interested in looking at these things. So how does the peak watt per kilowatt change the longer time periods we look at? For example, there's a VPK curve, something that they look at within sports where they can measure power easily in the training sessions. We'll not get more into details about it, but so when we think about this data now, we think, okay, we would probably want one observation for each time period, right? So if we think about, again, going back to the definition of tidy data, okay, we need to think, what should our variables be? What should be one observation? So when we look here, we see, okay, we want to compare the different time periods, right? So for each athlete within each training session, we want to see, okay, so what is the difference in peak VPK for a 5-second period to a 10-second period to a 15-second period, right? So we want to make sure that we have one row, one observation for each athlete, training session, and time period. Okay, so then we kind of decided what are our observations. Now we go to variables, right? So, okay, we need to know the athlete, right? Because we might want to look at this within each athlete. We don't want to have just all the training sessions, don't have any idea which training session is connected with which athlete. So this is a good column. It's a pretty long ID, but we're okay with that. We know that we will work within each training session. So we'll get this power curve, like power duration curve for each of the training sessions done. So this should be a variable for us to know, okay, which of the training sessions is this? And then we think, okay, we said we want one row for each time period, right? So now what we need to do then is, okay, we need to get one variable that tells us which is the time period within this training session within this athlete. So we'll need to somehow create one variable that defines the time period. And then we think about, should we have one variable that tells us if we're talking about the peak watts per kilogram, sorry, or if we're talking about critical power. And then we think about, are these the same? Could these be different observations of the same thing? No, probably not. These are probably two different concepts, right? Either we look at one or we look at the other, or we might want to see how these relate to each other. But the value, the critical power value, is not directly comparable to the peak VPK value, right? We can't say, for a 5-second bout, the peak VPK value is lower than the critical power. That would be like saying, okay, this athlete, does he run faster in the yo-yo test, or does he bench press more kilos? Like, these are two different concepts. We can't directly relate them to each other. Like, we can't compare one to the other directly in that way, at least. So, okay, these ones should probably be two different variables, have their own columns. So now we start to have an idea, at least a little bit. You'll see how we get there. But so now we have a bit of an idea of how do we want the data to look for us to actually start to work with it. So we have the raw data. Next step is clean the data, or transform, or calculate, or here we might want to do several stuff further along. The first step is to think, first step then is to get these values, the time, down as values in their own variable, right? And then we need to get each of these values on separate rows. And to do that, what we'll do is we'll use the function. What? Sorry. Good. We say we will use the function that is called pivot longer, is the one we'll look at. And we say, normally here it comes up a list with the different functions we can use, right? Something is weird here. We do the help, so F1 or the question mark in front. And we see that we don't really get a help page. We just see this thing instead. Help for topic pivot longer is not in any loaded packages, but can be found in the following packages. Okay, pivot longer is a function within the tidyr package, right? And again, we didn't actually load it. So we don't have access to the functions from that package yet. Then what we have to do here is we go back up. And this is the nice part of having everything in a script, that you can jump up and down. We need to load the tidyr package. Command enter, control enter to run it. And now we can see down here that we actually loaded this package. Just to take a short stop here and show you one thing more that we haven't looked at before. One way of seeing both which packages you have installed. Remember that the first class we did install packages, and then we wrote tidyverse, but we could have also just wrote the specific packages, but this is how we installed packages, so we have them available on our computer. And then we need to load it to get it into R. So install package to get it on the computer, and then library to load it into your R session to be able to use it. Under the packages tab, you can see all the packages that you have installed. So if we scroll here, this is all the different packages that are installed. And a lot of times one package needs other packages to work, so it will install more of them. So if you see a lot of things that you didn't actually install by yourself, it's probably because one package installed another package. But here you can scroll through. I have a couple of extra packages installed that you will probably not see. But here you can see, for example, that we have dplyr, the one we used last week. So this is all the installed ones. And then you see that some of them are checked, right? And now this is the packages that we have loaded into our R session, the ones that we can use. And we can see that there are some packages that are loaded always automatically when we start R. We haven't really worked with them, but just so you know. But here, each time we load a package, we will see that it will show up here. So if we go down to read R, we see that it's actually loaded. If we now would restart our R session to empty everything, so Command-Shift-0 or restart R. Now we can see, again, if we scroll down to read R, we see this is not loaded, right? We don't have it in our R session because we just restarted it. We just said, take everything out, restart from 0. So now if we start to run the lines here, we load the read R package, and now it's checked in. So this could be a good way sometimes for you to go in and check which packages do I actually have installed, which packages do I actually have loaded in my R session. Okay, that was a part. Let's continue here. We load the packages, we load the data again since we restarted. And now if I go back here and start to write, we see that, now I can use it. It shows up here, it's loaded, so we can use it. And what the pivot longer function actually does is it takes a data set. This is a very small data set, just to show you how it works. So we have, again, some rows, some columns, and when we pivot longer, so pivot is to turn. I don't know if any of you have seen Friends when they pivot no, sorry, wrong generation. I start to feel old now. So pivot is we want to somehow turn the data around, right? And again, longer means that probably we want somehow that it's more columns than we want, and some of them we want to kind of pivot in to a longer format. So some of the things that we have in different columns, we want to get into different rows instead. So what happens here is we have one row for A. This might be, let's say, athlete A, and we have 2 measurements. When we pivot longer, what happens is we'll take the names of the columns and put them into their own variable. So we have a variable that is, in this case, measurement, and here you see, so we get several rows. So what happens here is that for each value that goes from a column into a row, we duplicate the athlete variable. So the variable that is outside that we don't want to reshape, we're happy. This is the variable that we have and we want to keep it like this. This one will get duplicated several times for each row we create. So you see here in the row A, we had 100 and 120 as our two values. When we pivot these two columns, these two variables to a longer format, we need to repeat the ID for the athlete several times. Right? So this is what happens with our columns that are outside that we don't change. They get repeated as many times as necessary. The second thing that happens is that we have to tell the function which are the variables, the columns that we want to get from a wide format in several different columns into a long format to get in different rows. So we told that is these two variables that we want to go from being separate variables into being separate observations instead, from columns to rows. And then we see that these two names gets into the new variable that we created, that is measurement. So you see here, BP1 gets one row, BP2 gets another row. And finally, we can see here that, again, we've repeated the ID as many times as necessary. We got in the column variable names into a variable that is just where they have different values. And now the different values that was before in separate columns now get into the same column in separate rows. Did you manage to follow along in any way here? Good. I see someone nodding a little bit at least. So we'll show this in practice. Hopefully it falls a little bit better into place. But you see that at the heart of it is which of the different columns, the different variables do I want to get into different observations instead? So for our raw data, we said that ID was the athlete and the date was the date of the training sessions. These ones we don't want to get into the same column, right? These ones we're happy with how they are. Alexandros, you had a question?
Could we also do this with more than two observations?
Yeah, I will show you now with all of them, actually. So we could do this with how two up until how many variables we want to do. So hopefully I will show you, I will run through, and if you have questions, then come back and ask it again, because I think it will fall into place now. Same as always, we go to the help page. First argument, same as always, when we work with these packages, data, we have the data and we piped it into, remember the pipe was just take this and put it into as the first argument inside the function. And then we have the argument calls. So calls tends to be short for columns. So this is which columns do we actually want to pivot into the longer. So which are the variables that we want to take from this way and put them that way. Now we could do create a vector and just put all the different ones. Peak VPK1S, peak VPK5 5s, and so forth. But this will start to get really long, right? Imagine that we want to do it for all of these columns. So we have in total 26, the first two no, so we would have to put 24 different. This is too much, right? That we're lazy. Programming, we're always lazy. We want to do it the easiest way possible. Remember, one thing we could do was to choose which columns not to include, right? So we could do minus ID, minus date. These were the only two columns that we don't want. So we can do a negative select and say everything except the ID and date variables. We run it and we actually see, okay, we have the ID column left, we have the date column left, perfect. And now we have two new columns, name and value. So if we look at, okay, name, peak, week, PK, 1 second, 5 seconds, up. And if we actually remember view, you see it in its own, we see that, okay, so the new variable that is called name is just all the old names of the column. We look at the raw data, these were all the different variables, columns, that we wanted to pivot into a longer format. And we see that all of these ones that we chose now is values within a new variable called name. Perfect. Then we have a second column that is value. And we see here, we can just double check, but we could suspect that this should be like the different ones. So for the athlete 111768 DC, blah, 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 blah. For the 24th of April, 2020, the peak VPK over 1 second should be 8.55. For the 5 second, it should be 8.12 and so forth. We can just double check here. We go to the raw data and we see 11, 17, see, blah, blah, blah. This is the same athlete. We said the 24th of April, 2020, and we check 8:55, 8:12. See, okay, this is correct. We've taken the names and just like that, and we've taken the values that were before like this for each training session, and we put them like this. So this is the basics of how the pivot function works, the pivot longer function works. This could work to do the negative select. Can work if you want most of the variables except 1 or 2 or something. But once you start to work with bigger data sets, so if you, for example, if you would look at the full data set for the OpenCheetah data, the Cheetah data, you will see that I think it had about 250 different columns. So now we're working with quite a lot of columns, and it would be hard to have to kind of find every one that we want or that we don't want inside here. So I'll introduce one new concept that also works inside the dplyr, inside what we checked last week when we selected columns. And that is what is here called tidy select. So here is different. Instead of having to specifically say all of the different columns by their full name, we can kind of search for specific type of columns or variables. So starts with, for example, this one would then select all the columns that starts with an A. Or we could do all the columns that ends with something, contains, matches. There's several of these ones. Everything means all of them. and so forth. So I will let you look more into these ones on your own, but I will just show with it starts with. So here, instead of selecting these ones, what we can do in the calls argument, we can actually be specific about it here, because it's a new function. We don't really remember which are the arguments, which order. We are on the safe side. We actually write out the name of the arguments. We want columns that start with peak WPK. So peak underscore WPK. If we execute this now with the view, so we went directly into seeing them, we see here, we didn't select any of the ones for critical power. That makes sense because we actually didn't put them. But all the ones that started with peak WPK was selected. So now we get them, we have pivot them, we have moved them from columns to rows, all of the variables that we chose. Right? So this is how these ones work. To not have to write out the full specific name, we can find patterns, different type of patterns in the names, and use that to write shorter code. So we know we've got the peak WPK, but we also wanted the critical power, right? So what we need to do now is create a vector. Since we have several values, we need to kind of package them together inside a vector. So everything that starts with peak WPK, or everything that starts with critical power. We run this and we see, perfect, we're back to the same thing that we did before, right? So we matched all the same columns that we did before, or rather all the ones that we didn't exclude. So the tidy select, all the tidy select things are different functions to select the columns we're interested in. So again, tidy select is way to specify which columns we want to talk about without having to write out all of them by themselves. Perfect. So we look at this data and we say, okay, perfect, but it created one variable that is name and one variable that is value. Again, we work with more data, we jump between projects. This might not be so explicative, right? What is name? What do we want? What do we mean with that? What do we mean with the value? So we might want to name this something better. Again, what we do, we jump back into the help page and we scroll down and we see that we have names. Okay, so names and values. So we have like one set of arguments that seem to relate to the names and one that seems to relate to the values. Names 2 equals by default name if we don't put anything in here. Okay, now we're getting somewhere. This looks like it has something to do with this, right? Scroll down, names 2, specifying the new column or columns to create. Perfect. This is what we want. So comma to separate the arguments. Now we say names 2, and since we're working with text, we're not choosing any column that already exists. We want to create a new one. We call this one, we need to use the quotes, and we call this one maybe time instead, right? We said we're interested in the different times. Okay, perfect. We run it, and we see that, yeah, we've just defined a better name for this column rather than calling it name. And value, maybe it's not that bad, but we could give it another name just to show. So if it was names 2, then we have values 2, defaults to value, right? So values to, let's say that we want to call it measure, right? We run and we say, perfect. Now we have time and measure. These are 2 variables. Perfect so far. Now we're happy. We worked through, we iterated, right? We explored, we saw how do we get it how we want. Perfect. Now we're satisfied. What we need to do now is, again, save it into assign it to an object. So we take out the view part, because the view part is just to help us fast see the data. And we save this into a new data frame that is called perhaps data long. Option dash, that one actually doesn't show up. Again, option or alt with a dash to create the assignment operator. We run it, and now we see we have the raw data. Now we have the long data that we see more observations, a lot more observations, but fewer variables. So this is in line, right, with how it should work. This is a bad example since it's 2, so we don't actually get fewer columns. But we have the raw data with 132 rows and 26 variables. 46 of them, 24 of them, sorry, was filled with the values. The first 2 was just identification columns. And now we get just over 3,000 observations for only 4 different variables. So pivot longer. We'll take a 15-minute break. The last thing, just to see what we'll work with after, is this is really good. But again, we said that the peak WPK and critical power are different variables, right? So we said that this 8.5 for a 1 second VPK isn't directly comparable, isn't measured on the same scale as 1 second critical power. So we still have a bit of work to do, because we said that we wanted the 1 column for the peak VPK and 1 column for the critical power, but the time periods in different rows. So that's the next step, and that's what we'll look at in 13 minutes when we come back. So 30-minute break, take some coffee, whatever you want. I will. Okay, so we looked at pivot longer, where we define which columns or variables we want to, instead of having in separate columns, to put them in rows. And every time we do this, what happens in pivot longer is we take the names of the different columns and put them in each row, right? And then we take the values that is in that specific row for that specific column, and we put it in its own column. So just to simply show with a simpler example, just maybe it helps to click a little bit in the head. If we now only filter out the first row, so let's pivot only 1 row to see how that looks. So we want to filter out, for example, the first row where the ID is equal to all of this, and is the 24th of April 2020. So date equals, now we have a problem, sorry, because working with date is a little bit harder. You can read about it in the R for Data Science. What we'll do is, let's see. So we'll do like this. You don't need to know this. This is just for me. This is another way of working with the data. That's not important. But if we would have created here, let's say that we would have this data, X, that is just one row. So we see again, we have all the same columns. We have the ID and then we have the date. So just to show here, if we would take this X and pivot it longer with, and we can copy paste here, we want to, so the columns that we choose inside the pivot longer with the calls argument, these are the columns that I want to get into my rows. Everything that is not selected here, I want to keep them as they are and repeat them how many times necessary. So if we would run this now, and we view it directly, we see here that we get, again, the two columns that was outside the pivot that we didn't select. They are the same columns, they just get repeated how many times necessary. In this case, we know that we selected 24 variables, right? So we should have this repeated 24 times, which is correct, we can see it here. These columns are, again, they're untouched, they're the same, they're just repeated more rows with the same data. And all the columns that we selected, that is all the columns that start with peak VPK or that starts with critical power, the names of those columns get into rows, and the values get, instead of being one value in each column, they get one value per row. So this is just to show you again how it works. Back to this data then. We have pivoted it, but we said that we pivoted it too much. It got too long, right? We still want these values, the ones that says peak VPK, we want to have a variable that says peak VPK, and then these ones. And then we want one that is critical power and for all the different time periods. To do that, one thing we can do for this is to actually break up the names into several parts. So again, when we checked here, names to argument, here it actually says, so it's character because it's text, specifying the new column or columns, right? So this one will not do if we just put nothing, that's not interesting. If the length is 1, so we put one single name, we'll create a single column that has all of the column names, right? That's what we did. If we check the raw data, we see, the data long, we see one column with all the name, the full name of it. But if we read here, if the length is longer than 1, we'll create multiple columns. And then we'll need to use either name separate or names pattern. We'll look at name separate here. So we could say, but what we actually want here is to separate the part of the column name that is the variable, right? And the part that is the time. You see that these are two separate parts of the column name. One is that what we actually want as a name, as a column, and one is the time. So we want only the time inside this column. So we could say, we want to have two column names. We want the first one to be called variable, and we want the second one to be called time, right? So we want this part in one column, and we want the time part in another column. This would be the first step to keep working with this. Two names. So in names two, we say two. So we should create two columns. Perfect. We try to run it. And we get an error. If you supply multiple names in names two, right? More than one, you must also supply one of name separate or names pattern. So we actually need to specify this argument. We scroll down and check name sep, name pattern. So if names two contain multiple values, we can use either of these two. The pattern uses irregular expressions. That's a way of identifying parts within a text. We'll not look into that, but it's good to learn if you're serious about doing serious work with this. But the names sep, we can see, can be a numeric vector specifying the position to break. So which of the character, so if this, for example, we would put, let's try names sep, and we said like a number, so we want the first part, the variable part to be the first 3 characters, and we want the second one to be the 3. When we run this now, and open the data log, we see that it took the first 3 here, and here nothing. And the problem here, if we go back, if we take this out and run the original, sorry, we need to take out both of these. If we run it how it was before, the problem in this case is we can't really say, I want to get the first 3, or then we can count 4, 5, 6, 7, 8. We want the first 8 characters to go in the first column and the rest in the second. Because then we have this one, if we count 1, 2, 3, 4, 5, 6, 7, 8, we only get the first part. So we can't really break off into 2 columns based on how many characters. We need to find another way. And if we read here, and we'll continue to read, or a single string specifying a regular expression to split on. So when we have these ones that are called sep, we can say which kind of letter or character do we want to mean divided here. And if we look at the data, we see it looks like here it's the underscore, right? Is using underscore to separate the different parts, the different words or parts of the name. So what we need to do here is we want to create our 2 variables, and we want to separate the values. We want to separate the columns where there is an underscore. We run this, and we get a warning message. Expected 2 pieces, additional pieces discarded in 24 of the rows, these rows. Okay. We look at the data and we see peak VPK. So, claro, what happened? So, sorry, what happened here? Again, if we take this out, I just cut them so I can paste them again. We run the original. And if we look at this now, we see, yeah, this makes sense because it actually has underscore in 2 places. So it tries to break this into 1, 2, 3 parts. Okay. What can we do here? And this is I'm just trying to show the process here. Like you try something, it kind of half work, but there's some problem to it. So you take it one step at a time, and you say, okay, what can we do now? We see that all of them here are split into 3 parts, right? So what if we split it into 3 parts and then try to put these 2 parts together? And these 2 parts together again. That might work. So we might say here that, again, if I take these ones back, when we just try to create 2 columns and separate the different columns where there is underscore, we got the first and the second part. We need to keep the third part. That is what it says here, right? It expected 2 pieces, 1, 2, but there was a third piece that was then discarded. So then we think, okay, what if we have, so we have variable, that was the first, okay, but the second one is also variable, so we need to split it maybe into variable 1, variable 2, and now time, right? So now we say, take the names of the columns and put it into 3 different new columns instead, right? First we did 1, now we were trying with 2, but we saw that didn't work. We create 3 now. And these 3 is take the name and take the name of the column, and each time it comes an underscore, put it into the next column. So if we run this now and look at the data, we see that now we have it in place, right? It said peak underscore VPK underscore 1 minute. And now we divided it each place where there was the underscore. So we have peak, we have VPK, and we have the time. Perfect. We got the time part out of this. This is good. This we like, right? So we're getting somewhere. Next step now is we need to put these 2 together again, right? Because we want the variable name to be peak VPK in critical power. And here, there is several different ways to figure out which is the kind of which functions could we use to do this and everything. But I said last week that most of the packages has web pages, right? We said there is the CRAN part. CRAN is where you install R from, that has an information page about each of the packages available and who wrote it and those things. Here. So that was, if we are working with a tidyr package now. So if we put tidyr CRAN, we go here, we see CRAN with our logo, we go in, and here again we could see the description, a lot of information about version, which other packages it depends on, these things, blah blah blah, who make it, and so forth. Vignettes were the longer text with like explaining more in in detail. This web page is kind of ugly, but you see that it has its own web page. And a lot of times this is the best place to start. You don't have to go through Crank. You could just Google the name tidyr, and most of the times the first thing that shows up is the web page of the package. So we go in, we see here tidyr, it explains a little bit, help you create tidy data. That's what we've been doing, right? It explains a little bit short, like every column is a variable, every row is an observation, every cell is a value that we talked about. Here you have articles. Articles is just the vignettes, so the longer text explaining, and we can say pivoting. Okay, so here we find more pivot longer, pivot wider. There's another one, and we can scroll, and here it explains it more than in the help page, so it talks through it. So this is a great help. For example, if you now next week that you work with these things, I don't remember exactly how was it, but I don't want to go through all the video with the class. Go into the web page, look for the articles on, see if there is anything here. And you can read pivot longer, and you can start to read about it. Perfect help. This is one part. Another part is reference. Under reference, you will find all the different functions available in this package. If you're lucky, they're kind of grouped by what sort of general things they do. So we see here pivoting, the pivot longer. If I click on this one, I go, this is just the help page. Same as the help page with arguments, details, examples in the end that you have in the help page. But here can also be a good overview of the different functions available, and that can kind of help how to do this. Like pivoting, no, like we were working with pivoting, but now we want to put two columns together, right? So that's not really pivoting. Rectangling turns deeply nested lists. This doesn't sound familiar. We keep going. Multiple variables are sometimes pasted together into a single column. And these tools help you to separate back. So here we have like separate. It sounds like we have one column that we want to separate into two columns. We're right, and then we continue, and we have unite. Unite multiple columns into one by pasting the strings together. This might be something, right? So we click on it. We go to the help page. We could have just, now that we find a potential function to use, we could have just here done question mark unite, and we go to the same help page here, just to show you that this is the same help page that is also available online. Convenience function to paste together multiple columns into one. This sounds correct, right? You can always take a little bit peek. It looks the same, data columns, separator. We recognize that from the name sep, right? Here, sep again. We scroll through. Here we can read more on the arguments later. And a lot of times the first place to start to look is in examples. Okay, so here they do something to create the data frame. And then they say unite, they take that data frame, so this data, they unite it. And we have sed x, y. So we can see here, this is the original data. The set column wasn't there before, it's new, right? So we can see, okay, sed, here, sed was the first argument, and here it shows up again. We can scroll up and see call the name of the new column. Okay, so they created a new column. This was just the name of the new column. Next, we have X and Y. Okay, so X and Y is the names in the, and we see here, it takes the X, takes the Y and it looks like it puts them together in the new column with an underscore. Okay, we can see why is it an underscore? We scroll up and we see like the separator between the different parts is an underscore. Right, this is the default. If we don't specify anything, it will do it with an underscore. Okay, this looks correct to us, right? This looks like it's worth it. This might be the thing to try. So we go back to our data and we now say, okay, we have the data long. We look at it. We want to put together this column with this column, right? So we do. Do we need to have this data saved to now work with new data? Or no, not really. This is still like within the same general step of getting the data into a longer format. So we just continue to pipe it into the next function. So again, we can use these pipes, the thing that takes this, puts it in the first argument. What comes out from the pivot longer is still a data frame, right? So we can just take that data frame and pipe it or push it into Unite. Perfect. Again, data frame that comes out of pivot longer is the one that goes into Unite. So the data, that's the first call. Okay, what do we want to name the column? And we said variable 1 and variable 2. So when we put these together, a good name could probably be variable, right? And again, it doesn't exist. We need to put quotations to say that we're working with text. And now we see the 3 dots, columns to unite. And again, we see the title select. So we could say unite all the columns that starts with variable, right? So here we could either do, we could say that we want to unite variable 1, right? Variable 1 and variable underscore 2. Variable 1, variable 2. We run this, we check the data, and we see it united it for us. So we took the raw data, we pivoted into a longer format, and that data frame directly, that data that came, we pushed it into Unite, create a new column that is variable with pasting together these two. Might be that we, for some reason, want to, like, we can work with a sep, right? The separator to use between values. So if we here put sep as a new argument, we could do something else. We could do 3 big X. We look at the data, and here we see, now it took the first part, put 3 X's in between, and it put the second part. Probably know what we like. Like, there's a reason that the that the default value for this argument is an underscore, because it's the thing we normally use to separate different words or different parts inside R. So we could just either, again, put an underscore, so it's with an underscore, or we could just leave it blank since it's what is default. So now we actually got the data into a long format. Again, long format, and we managed to separate the part of the column names that was actually indicating which type of variable we're talking about and just the time period. So now we have our data in the very, very long format. But again, we said that we wanted 2 columns of values, one for peak VPK and one for critical power. And this is where the next function comes in. And the next function is kind of the opposite of pivot longer, pivot wider. And again, if you imagine that pivot longer was take a lot of columns, put them in rows, then pivot wider is take several rows, put them in different columns. So we have our data long, right? This is the data that we just created with our columns. We should put some nice explaining what we do. Get time periods, or rather get variables in rows. And here we get the two variables into separate columns. Just to remember what we are doing here when we go back to this later on. So we take the data long, and now we do the opposite here. Pivot wider. And again, if we're not sure, we could have checked the web. We had the reference, right? Here we had pivoting, we have pivot longer, and very close to pivot longer is the pivot wider. Or we had the article on pivoting. So we here, if we would have had more time, get into this, check. And then we have here, this is the different headings. So we have wider. Okay, pivot wider is the opposite of pivot longer. Makes it wider, makes sense. Goes through the example here, blah, blah, blah. And then we could maybe have checked longer than wider, right? So some problems can't be solved by pivoting in a single direction. So here it looks like it might actually go through the same thing we are trying to do. Having it very wide, so we have to pivot longer. And after we pivot longer, we need to pivot it wider. So this is the way that we can find out which functions could I use now to move to the next step. Pivot wider, we check the help. And again, first is data. And then we have the 3 dots that we see here, additional arguments passed on to method. This doesn't look like anything interesting. Then we have ID calls. I will explain a little bit more later. But here we have names from, values from. Okay, pivot longer, we have names to, values to. So they kind of sounds like the opposite, right? So names from, if we read further here, the column or columns to get the name of the output column, and then from which column do we want to pick the name for the new columns that we're creating? And then from which column do we want to take the values that we'll now put in the different columns? So here we could do, we say names from, and then we go back to look at the data, and we see, okay, so we said it was what it says here in the variable column. This is the ones that we want to get into different column names, right? So names from variable. And now we need the second one, that is values from. Okay. Again, we check and we have the values in the column that is called measure. So we put measure. Now we run this and we just have a quick look. We have the ID column, we have the date column intact, right? We didn't touch them up here and we're not touching them down here. We have the time column that we created before, right? We created it for the long data, but now we're not touching it. We're not saying, get this into the column name again. No. So that one is left there. But the difference here is that we see that we have peak VPK and critical power in 2 different columns. So we said, take the column in the long data that is called variable and create a new column for each different value that exists. In this case, it's peak VPK and critical power. For each of the different values that we have in this column, create me a new column. So it's what it did here. And then it said values from. So when to fill up these columns, to fill up these two columns, from where do we want to get the values? We want to get it from the column that is called measure. So here again, if we check, we have time point 1 second, peak VPK. Okay, so here we can see peak VPK 1 second. 1 second, 8:55. Perfect, it's here. And now we can then see 1 second critical power. So we go down critical power, 1 second, 419. Perfect. So this is how we worked with taking the data that we had in a too wide format, pivoted it longer, so create more rows, but we created too many rows because we had two different variables that we didn't want in separate rows. And then we worked a little bit with the data, right? To separate the parts of the variable and then putting them together again. And then at the last part, we said we have this that is too long, and now we make it wider, a little bit wider again. But we keep the different time points in separate rows. So now we can feel satisfied about this. What we could do here, like just to show you, again, this is not what we want to do, but we can do the same here. In the pivot wider, we can use names from. It says which column or columns. So we could use several here if we wanted. So we could have potentially here names from, which is the names from the variable column and the names from the time column. If we try to run this now, we see, now it created a new column for each value, each combination of the value in the variable column and the value in the time column, right? In this case, it's kind of worthless because this is the data we started with, right? This was the data we had from the beginning and how we knew that we didn't want to have it. So obviously in this case it's stupid, but there might be cases where you have several columns that you want to put together in the like you have several columns with values that you want to combine these values to put different columns. So that's how that works. Again, we didn't want to do this. Didn't want to have several. We wanted to only have the variable. So we actually got the data into the format that we wanted. We run again. We double check. It looks okay. Okay. Now we feel satisfied with the data, right? So we say this is the clean data. Clean data. Sign it here because this we're happy with. Again, what we don't want to do now is just to run in and start our analysis here in the same script, and then it gets super long. We have 34 lines now. These ones can easily turn into 200, 300, 500 rows, and it just gets hard to read. So it's better to keep these things in separate scripts. So each script do basically like one thing, and then run it in a new one. So what we will do is we'll say we took the raw data, we tidied it or cleaned it, and now we want to save the clean data to work within another script. So we create a new section that is save data or write data. We could use write data because again, Now we have the data in our R session, but we don't have it, the new data, the new clean data, accessible from anywhere else, right? So here we want to write the data, and again, a lot of times these functions comes in pair. We had read CSV to get it from the hard drive into R. To do the opposite, we can just use write CSV. And we're going to use the version with underscore, the one that comes from the read R package, not the one with a dot. They work a little bit different. It's a little bit easier to work with this function. Check the help. Okay. X file, these are the most important. X, the data frame or table we want to write to. So it's the clean data, right? That's the finished one. Clean data, either put it here, or we can put clean data and pipe it into. Remember, if we have something outside pipe, it goes into the first argument. Then in this case is the data frame. And then we need to tell it the file or connection to write it. So this is in the hard drive. When we go through our folders, where do we want it to be? And remember that we always start to count from where the R_proj file is. So this is where the project starts. So we can now just save it and call this clean data, or maybe clean training data .csv. We need to specify that it's a CSV file, otherwise the computers won't recognize if is this a CSV file or a Word file or an Excel file. So we need to write it out. If I now execute this one and we check the files, we see that we now have the clean training data. This is how we did last week with when we created like a summary table and then wrote it. But here we do it this way. Again, we save, have everything saved, and now we can now we could go in and do analysis. So we could close this down. Again, restart R. On Mac is Command-Shift-0. Should be similar on Windows, like Control-Shift-0 or something. We create a new R script that we call, let's say that we want to plot the peak VPK curve, right? We're explaining pretty explicit what we want to do with this. Perfect. So we save it. And now we can start just as we did last week with loading packages. So we load the readr. Library readr. Library. We knew that we wanted the dplyr maybe to work with the text or with the columns and everything. Yeah, question?
Is it possible to load all the packages with one command?
Yeah, it is. You could do here, instead of putting them as separate lines, we could just do a vector with all the ones. So here we could do inside the library, just create a vector. The C is for creating the vectors. Concatenate is what it stands for, doesn't matter. We put the dplyr in here as well. And now we can just load. No, sorry, sorry, my fault. We can install packages this way, but we can't load packages this way. We need to, my fault. So if we're installing packages, we can install them all at once. But when we load packages, we load them with separate calls. And this helps a little bit to keep maybe a clearer view also of which, like we have a single line for each of the packages. It's easier to go back and check, finally we didn't need this one, okay, perfect, and so forth. So the answer is finally no, sorry. Again, I will just show quickly here. We want to read the data, and here again we have we want to have the training data. How we call them here doesn't have anything to do with how we call them in the other script, right? So when we look at the steps for cleaning the data, we created the different steps, different data frames, like different objects at the different stages in the data cleaning, in the data tidying. Once we finish and write them to the hard drive, so we have an here, and we restart R, now we can just call them different things. That's not a problem. So the important thing is that we call them, that we are constant inside the same script. Just to show here, read CSV, now we read the clean training data.csv, and now we have it ready to analyze. So now it could be next section could be create plots, and now we could do training data. We need a ggplot, so we didn't actually need the dplyr. In this case, we needed the ggplot2, which is the package for plotting that we used the first week. And again, ggplot. Here we see the aesthetics, like we went through. We check the training data, and here we say we want to have time on the x-axis. So on the x-axis, we want time. On the y-axis, we wanted the peak VPK. Peak VPK plus, and here we want, maybe instead of dots, we want to have them connected, right? Because they're within the same training session. So here we want to do a geom line. And then we'll just need to group them. We check the help for geom line. Here, scroll down, and here we can see the different aesthetics. So we can use group, because if we just run this now, we get just a bunch of groups, because we don't have one line for each separate row. So in this case, we want to group by ID. Here we still have a problem. Why is this the problem? Because we have several 1 second measures for the same ID. So here, then what we do is we do one for each ID and date. Sorry, we need to. This is not something. It's just to show you. Here we see now we have one line for each. The problem here is that they are not in order. We would have to work with that, as we went through last week, to kind of transform variables. Here we could create a factor, read more about it in the R for data science. Just showing here, bad plot, we need to work more with this. That's fine. But the thing I wanted to go through before we jump into the last part is, once we're happy with this plot, we say save plot. And now we want to say this plot, we want to call it peak WPK plot. So we save it as an object. And now we use write CSV to write the CSV files, right? The data frames that we have. For saving these plots, we use the ggSave. And here we go into the help. And we see first thing is file name. So here we have a little bit different order. First is the name. This is why it's good to read the help to see. So we say that we want to call this new plot that we create PWPK plot, because this is the name that we want to give it on the hard drive when we look among the files. And these are the names that we have inside our R session, so in the environment. They disappear once we close down this. So that's why we might want to save it. We save it as a PNG. Now we see plot is the next. So, okay, plot, we said that we wanted, is this one that we want to save. And if I now run this and check in my files, we see that I have saved this plot. Not the nicest plot, that's another thing, but again, now we went a full data science project, full analysis project. We did it bad. The last part we did bad. Here it needs more work and everything. But again, we took data from somewhere that was not in the correct format. We read it into, so we took this data that was from outside. We took the data, read it into our changed it up, so we made it longer and then we made it wider to make sure we have the correct columns and everything. Once we're happy with the data and have it in the format that we have, we save it. So we also always have the clean data saved, so it's easy to find and easy to use in another application or program if we would want to do that. And then we have a new script where we read in the clean data and we do whatever kind of analysis that we are doing. And then we save the output into, in this case, an image to show the plot. So now we went, let me get this up, all the way again. We imported, we didn't check different options. We haven't gotten really into the details here, but we did it. We worked a lot here with tidying the data, changing shapes of it, getting it longer, getting it wider. We didn't do any transformation, but we could have. We visualized it, and now we found a way to communicate it by saving. So we did full project. We take a 10-minute break. Sorry for the shorter break, but we'll take a 10-minute break and then get back to the last part. Resume the recording. So the question was about once we have the clean data and are analyzing it, that I hear inside the ggplot used one aesthetics that is called group. And the reason for this is, so the x-axis is kind of easy. Like, I mean, which variables go on the x-axis, which go on the y-axis. We didn't look at it, but if you look more into the chapter in the book on visualizing, you will see that there's a bunch of these different aesthetics. So for example, if we look here, we could have done, again, all the geoms, so the different way of actually putting the data in the plot. If you scroll down in the help page, you will find one section that is called aesthetics. And this one talks about which kind of aesthetics does this geom need, the ones that is the bold, and which ones can they have. So here we see that there are different, so we have the X and the Y, we have color. So we could here have done, hang in with me, I will explain the group part, but here we could have done, for example, we could have said we wanted each athlete to be a different color. So here we could have put ID because it was the name of ID was the one that defined each athlete. So if we would have put the color here, good. We save the plot so we don't see it directly. So we need to save it into an argument, an object, and then run it. Now we see here that we have a different color for each of the different IDs that it exists, right? So this is again how we map the different aesthetics. For some of them, for some of the geoms, so the different ways to represent, here we did it with lines. We could have also done it with points, right? And we look at it. The problem here is that with points, for example, we don't see the connection between them. We don't see inside each training session how are these connected. For the geom point, you almost never need a group argument, because generally, if you want, for example, like each point here, I mean, you have the different time points, you have the different values for it, you have different color depending on which is the which athlete it is. So you just create one dot for each observation, each row. The problem with the line one is that that's not actually what we want to do. I mean, we don't want to create one line for this athlete, this time, this date, for this time, right? We wanted to create a line that goes through here to here to here, all the way down to here, right? So this is why we need to tell ggplot which observations, which rows to group together to one. Because if we don't, if we would have completely taken this out, we can actually do it like this. If we would have completely taken this out, then we get, and we do geom lines. Then we just get lines that go through the different points, right? It doesn't really know, like, between which of the rows should I draw these lines. So that's why you need to tell it to be explicit about this. And that's what we use the group for. We could have done the same here with just the color instead of the group. Like, the group is a way of saying group the lines together based on this variable. And the reason why we do paste, this is just to put these two columns together, because it's not just ID, it's the date also. Now, since we identified them by the different athletes by color, we could have just see. So if we just do that now, then we would get, we see the different ones have, the different athletes have different color on their line. But again, it doesn't connect between the different rows, only within. So here it will connect the green line here for this athlete. The line, what it thinks by itself is, all the observations, all the rows for this athlete inside the 1 second, we put together. But we want to put them together all the lines, like all the observations that are grouped by the date, so the training session. So this is why we now do them group equals date. And when we do this now, we see that we have, again, now we separated the athletes by their colors. And now we have, so this green line, for example, is connected. It groups together all the rows where that has the same date for that athlete. So that's just what we do with, that's why the group one works. But you can read more about it on your own. I won't go into more details on it here. That's part of the self-study. Okay, so now going back to, if we look at the data we have, okay, perfect. We have the athletes, we have the dates, we started to create this peak VPK curve. So the power duration curve, although it's not in the correct order right now. So if we look at it, that's why it's jumping, because we didn't fix with this. That's again a self-study thing for you to look at if you're able to figure out a way to fix that. But what might be interesting here is to be able to do this, for example, for males and females separate, or for different. So like we might want more information on the athletes in this case. And now is where we start to get to the next step, because we had that, right? Athlete CSV. If we just open this one, just for me, it opens in Excel, it might be different. Here we see that we have column that is ID, so the same as in the other one. Year of birth. Okay, so we know when they are born, gender, male, female, and the athlete weight. Okay, so this might be nice extra information to have with the data for when we analyze it, because again, we might want to separate male and female. We might want to start to check, is the critical power higher or lower if you're older or younger? Does it depend on weight? These kind of questions, right? So we want to get this data in with the other data. So this is the next step. Now we have the full project, right? From the raw data to the cleaning data, the clean data, doing some analysis, presenting it. So now we just reiterate over this one. We just continue to improve within each of these files. So we don't need to create a new one for everything. So we just, again, restart R. So we're working here. We think about what is the first step. So the first step was to clean the data, right? Here, clean data. And this is where we read the raw data, the training data. But here is where we now want to include information about the athletes. So we want to put together the two raw data sets that we have. So our clean training data have the information about the sex of the athlete, the weight, and these things. So that's why we go back into the clean data script. Here we will want to do something more. Okay, we have the raw data, the raw training data, but now we also want to get the raw athlete data. So, okay, we need to look through here, raw data. Okay, we can't just call it raw data anymore because we'll have two raw data. We need to change this. So we will call this one raw training data. Now we could just go in here, change, go to the next place, change. So like change, but it might be if this is an object that we reference, that we use in the code, a lot of times it's hard work to go in and change it manually everywhere. But it's also the problem of maybe I missed somewhere. So then we don't have, it doesn't, we cannot run everything. So what we can do now is, if we mark here, if we do Commando F or Control F for finding, if I already had this marked, I get here. Otherwise, if I just click directly on Command F, I'll have find and replace. So here now we could do, we want to find every instance of raw data. And then we see it marked, nowhere else, but it might be that we have it in several places. And now we want to replace this with raw training data, to be more specific. And here, if we just find, we can just click here on next to go through all the places that this exists. And if not, and we can go back, blah, blah, blah. And here again, we can replace. Then we go one by one, replacing in each place. Or we can just, if I know that this works fine, I only have marked, like found the places that I really want to change it in, I can just click replace all. 2 places, okay? And now we see raw training data instead. Perfect. So Commando or Control on Windows F is to find and replace. So good tip to use. Now we need to load the other data as well, right? So we run these, we load the packages, we load the raw training data, and here we want to add raw athlete data, which will be read CSV. And again, we start from where the art project is, and this one is just athletes, just athletes.csv. Okay, perfect. Now we have this data as well. It looks the same as it did when we checked it before. So we just want to merge this one with this data with this data. Perfect. To do this, we work with a couple of functions that exist in dplyr. So remember the package we worked with last week that was to transform and those things. That package also have functions for joining together 2 data sets or more. So again, first place to start, a lot of times, search dplyr. We go here. We can check articles, 2 table verbs. Verbs, remember that is just a way of saying function, since they are written in verb form. Do this, mutate, select, blah, blah. 2 tables. So we have 2 data frames or 2 tables to put together. Perfect. And here we see again, it's a vignette, so it's a longer type, explain with examples and everything. So here we could read more about it. Perfect. We see that these ones are called anti-join, semi-join, full join. Perfect. We could also go to the reference. Check here. We could go through which are the different ones. Data frames. Here we check. Okay, here we have a bunch of functions that are called join. And these are probably the ones we want to work with. So I go in, I look, there are separate inner, left join, right join, full join. So it looks like there are several different ways to combine these ones. And there are, and the main ways of combining, now I see that this was a really bad quality picture. But there are couple of different ways to join these ones together. We will just touch on one of them today, then you can explore the other ones. But basically how they work is, let's say that we have one data frame, the blue data frame and the green data frame, right? And we have a common column here that is the ID. So we want to say, this is one interesting variable, this is another interesting variable. We want to get them into the same data frame where we have a row for each ID. ID could be athlete or whatever. And the different ways of joining them will create different new data frames. So for example, if we do an inner join, the inner, and you can read up more on this, and I think it's good because it comes back to, it's the same if you ever work with databases and these things. Inner join will only take the rows in this data frame where the ID has a match in the second data frame. And the same. So it only takes the rows from the data frames that match in both of them. So we'll end up with ID2, X1 and X2 is these values. And why is this? So if we look here we have two athletes or whatever we talk about, 1 and 2. And in the second one, we have 2 and 3. So the only ID athlete that is common in both of them is the number 2. So this is the inner product, the one that exists in both of the tables. And then we say, okay, so we want to get this row and we want to get this row. And then we want to get the columns. So we have like all the other information, the X1 and X2 variables. Left join says, let's take all the ones in the all the rows in the first data frame. So the left data frame, if we think we have the left and the right, take all of these rows and put in all the rows from the second one that matches in the first. So what we will end up here is all the rows in the left data frame, the blue one, but only the rows in the right or green data frame that has a match in the first. So it's here, ID 1 and 2, we have both of them. We have the values from this column. And then we remember that the 2 existed in the second data frame, right? Perfect. So we take the X2 value and put it in here. But for the 1, we don't have a row here. We keep the row because we said we want to keep all the rows from here, but we don't have any value to put in the X2 column that comes from here. The right join does the opposite thing. So the right join will say, we want to keep all the rows from the second data frame, the green one, and we want to add information from the first or the left data frame where it exists. So here we say that then we end up with the 2 rows of 2 and 3 instead. We end up with all the data from here, but from the first or the left data frame, we only end up with the data that has a match. So the one of the ID2. So these are the same, just which of the 2, the left or the right, do we want to keep all the rows? The full join says we want to keep all the rows from here and all the rows from here. And when they match each other, perfect, we have 1 row. And when they don't match each other, we just miss the data that doesn't exist in one of them. So here we want to have all the rows from both the data sets together. And these are the main ones. Then these two semi and anti-join is we will not, that's not important. We don't need to look into that. So that's how the joins work, the different options. If we go back to our data, we say here that we loaded both of them. We cleaned the raw training data. So we'll go through these steps. And here is the same. We might want to say data long, that doesn't really explain. We want to be specific that we work with the training data. So long training data. Sorry, data training long, we said. Here, perfect. And then instead of just clean data, we want to have clean training data. So we run these two now. If we are unsure if we already ran these ones and we need to go back and jump and it's problem, we can always restart R and start from the top again. So we run this, run. We have up until the clean training data. So check the clean training data, it says we had it before, but now we want the raw athlete data. This one. So first things first is, do we need to clean up anything here, or are we happy with how it looks? Do we need to get it longer, shape, change? And no, it actually looks pretty good. So we're fine with this. We're just going to go with it. Perfect. Now what we need to do is, before we write the data, we need a new section, because now what we want to do is merge data or join data. And now we could do, we could start with a left join. Sorry, again, it doesn't show up. This is a indication that something is not, we're missing something because it don't show up in the list. And again, this one we're in the dplyr package, right? When we looked in the website, when we're looking in the website, the dplyr, not the tidyr, we don't have it loaded. We need to load the dplyr, so we add that one to it. Now if we do left join, perfect, now it shows up. We check it and we have X and Y and by. So we scroll down, a pair of data frames. Okay, so the X and the Y is the two data frames we have. So we have the raw athlete data, and we have the clean training data, right? These are the two. And again, we could take out the first one and put it before and pipe it into. That works also. So we can instead say we want to take the raw athlete data and we want to do a left join with the clean training data. So what we should get here is, we should say, take each line in the raw athlete data and add the rows from the clean training data. Let's run and check what we get. Okay, so we get 1,584 rows, which is the same as here, right? The thing here is, this works fine for us now because I know, since I prepared the data, that if we look at the raw athlete data, we have 9 athletes, and I know that these ones match exactly the ones that is in the cleaning data, right? I know that this is the same athletes. And now we could do just a quick check. What we can do is, we could just to check is, do we actually have the same values? We could do clean training data, and we do, remember the distinct that we worked with last, get all the distinct or unique from the column ID. And when we run this, we see, okay, 1 to 3, 1 to 9. Okay. these are the unique values of the ID column in the clean training data. When we take the raw data, we say, here is 9 as well. Perfect. So it looks like, and we can double check and they match. So here we don't have a problem because it's not that it, in some cases, we have training sessions in the clean training data from an athlete that we don't have more information on, or that we don't have more information on an athlete than what we have. We have information on an athlete, but then we don't have any training sessions for it. So in this data, it doesn't really matter which one of them, which of the different type of joins you use. But for example, if these ones wouldn't match completely, then the left join would say, we want to keep all the raw athlete data rows, even if there is some that don't have any training sessions. And then if there is some training sessions that doesn't match the ID inside the athlete data, then just skip them, don't include them. Again, read up on it by yourself. There is, it explains it in the R4 Data Science book. You can read the vignettes and get into the details of these things. But I just wanted to show you that this is how you work with the different joins. The most common one you will work on is with the left join. So that's how that works. When we run this, if we scroll up a little bit and read what it says here, we see that it says something before printing all the data. It says joining with join by ID. And this one, if we go back to the help, we see that there is an argument that is called by. And again, in this case, we knew when we looked at the data, so we look at the raw athlete data, we look at the training data. Sorry, we can look at the clean one. We see that which is the column that we want to be identical between the two. And in this case is the ID, right? The date only is in one of them, the time, like these ones are unique for the clean training data. And here we see that these 3 columns are unique for the raw athlete data. The column they have in common, so the column to say, this is the column to match the rows on. So when this is the same value, you want to match them, it's the ID column. And the joins can guess this. So if you don't specify anything, it will say, okay, is there any columns that look the same in both of them? Okay, we guess that this, I guess that this should be the column to join by. But we can be and should be specific about this. So it's better to actually write out by equals join by ID. And now if we run this, since we're explicit, we put it in the argument, we don't get the text about it because it doesn't have to guess anymore. So this is how we join. Inside the join by, if we read the help, we see that this is a help function. This is another function to help us with this. There's a bunch of different options. We could do when one column is equal to another, when column in one is bigger than column in the other. Like you can do really advanced joins on different type of, so again, there's a lot more to explore here and you can start to do some pretty advanced stuff. But the basic of it is take one data frame, take the other data frame, see which is the variable that exists in both of them and put them together. We can also do, if we scroll down to examples, it might be the case that these two are called different things in the different data frames. So it might be, for example, that we think that ID isn't that good of a name, So a part here, when we have the clean training data, remember we take the data that is too long and we put these ones back into separate columns. In this stage, we might have wanted to say, but we want to change name of the ID column. We don't want it to be named ID. We want it to be named athlete ID. So here then what we did, we might have done, so we pivot wider and now we use the rename, that is another of the functions in dplyr, similar to select, but to rename stuff. We didn't look at it specifically, but go to the webpage and read about it. And here we might have said that we want to have a column that is called athlete ID, and that is just the name of the ID. So we rename the ID column into athlete ID column within our clean training data. So when we execute this, if we now look at our clean training data, we see that it's called athlete ID, right? But in our athlete data, the column that has the values that we want to match them on is called ID. So it has a different name. If we now would have tried to just run the join directly by itself, again, remember we changed here, we renamed the ID variable. So when I try to join them together, I get an error that says that the argument by must be supplied when X and Y those have no common variable, right? So if we check, there is no any variable that has the same name in this data as in this data. What we can do now, if we have it that way for some reason, is if we have our by, join by, and here we could say, what is the name of the column in the first, in the left data frame, the raw athlete data, is called ID. That we want that one to be equal to, remember from the filter last week, something equals to, okay, when it's equal to which value in the right hand data, so the clean training data, matches the athlete ID. Okay, so when ID in raw athlete data matches the value in athlete ID in our clean training data. We run this now, we see it works. Gets the same rows, and we have our ID here. When you have different names, it will use in the new data frame that we create, the joined one, it will keep the name from the left data frame. Just so this is how you can work with it, even if they don't have the same name. Again, in this case, that feels stupid, so we just go back to, we don't rename this column because it didn't have that name finally anyway. Here, we restart R to make sure that everything runs in the correct order. We try to run things again. And now we join and we see this works. Perfect. Now we have the full data, right? We join the two data sets. So we create a new object that is joined data. And now when we have the finished data that we want to write, remember that we want to save to use in the analysis. Now is not anymore the clean data. Now the last step was the joined data. So the joined data is the one we want to save. So we have the peak VPK, the critical power, but we also added information about the gender and year of birth. So we change here from clean data to joined data. We run it. And now if we go in and look, so we save, again, we think we're done with cleaning the data. We updated how we clean the data, how we want the final data to look. We've done this, so we close it down. We close down, we restart R. Now we can open the plot, like the analysis script again. And now we check the training data and we see, now we have the information about the gender of the athlete in here. So now we've actually joined these two different data sets into one that works better, because let's say that now, for example, this plot that we created, we might say, but we want this one separate for women and men. So inside where we create the ggplot, we add, in this case, facet grid, and we want them in next to each other. So we want the calls, like we want separate columns for the variable gender. Sorry, we're talking gender, not sex here. If we now run this, have our plot, we see that we get one for the female athletes and one for the male athletes. So again, now we're moving on here. Again, once we're happy with it, we save it, and now we can check here, or we can check here that we have our new plot. Perfect. So this is how we then, in an existing data science project, we said, we want new information that comes from another data source. Let's update this, do it again, run everything again. You see that you don't have to go through, create the plot from zero. You can just redo it. Perfect. Now we also know how to save the plots. We know from last week how to save the tables that we create. Everything is good. However, you might imagine, let's say that we have 10 different data sets from the start. So the raw data is 10 data sets. We want to clean the data, and then we want to do like 5 different analyses on this. You see that it starts to be a lot of files in the project folder. And this is when we want to start to use subfolders and have a clean, standard way of organizing our projects. And there is a little bit different ways to do this. I will upload a paper that talks about this, that names them a little bit different, but we need some kind of organization. My strong suggestion is something like this. So we can create a new folder here in Finder on the Mac, or where you do it normally, but we can also do it directly here in R. My recommendation here, my strong recommendation, is have one folder that is data raw. And in this folder, you put the original data, so the data that you get in this, the athletes, the training sessions that you get, don't touch that data by itself at all. Just let it be as you got it, because then we work with cleaning the data. So in this one, in this folder, a tip is to put the original data, so athletes, training sessions, this is our raw data. We drag it into the data raw, and the script for cleaning the data, because this will only be one script where you take all the data you need, you do all the transformations, things, pivoting, joining that you need, and then you go down and have one final clean data set. So I would definitely put these ones into data raw or raw data or something, data raw. Next thing I would do is we have one folder that is called data, and this is where we save our clean data. So the one that we create from our clean data script, we want to save it inside the data folder. And then and again, the only thing we can't recreate that we need to save is the original data. The clean training data, we have the script to recreate it. So if I now accidentally delete this, okay, I don't have the data to work with, no problem. This is why it's good to work in R, because what we can do now is go into my project, go into the data raw and open the clean data. We run through. Here we have a problem, remember, this one starts, the file path starts from where the R proj is. So now if I try to load, this doesn't work because there is no training session CSV here. It's inside the data raw. So I just need to add data raw / for when you're inside working, like you'd specify folder inside the folder with a /. If I run this now, it works. Same, I need to do the same here. Data raw, load my athletes. We do the cleaning, we join the data. And now we said, we don't want to write the data just directly into the main folder. We want to write it into the data folder. So we just say data / clean training data. If we run this now, we see here it didn't show up anything. If we look inside data, there it is. Perfect. So we managed to recreate the clean data from our script, and now we have it, start to have it organized. Next step in the organization would be to have one folder where you put all your analysis scripts. So I tend to call it analysis in singular or plural. So analysis, we have that folder. And I put, so if it's easier to drag and drop here, we have our analysis script, the plot VPK curve that we put into our analysis. Again, this one, the plot, we can just recreate, right? We have the script to recreate, so we could potentially just delete this. No problem, we can recreate. We go in, we go to analysis, open our script. Same thing here. We cannot just read the data because we don't have the data directly in here. We have it inside the data folder. Same thing here, data / we load it, we create the plot, we check that the plot looks good, which it doesn't, but we ignore that. And then it's good practice to save, because it might be that you're starting to create a lot of different plots, right? 10, 15, and you have some plots and some tables and blah, blah, blah. Same thing, create a folder for that. So we create a folder that generally is called something like output. And now, again, we want to save the plot, not directly into the project folder, but into the output folder and then the plot name. We run through everything. And if we check now inside output, we have it here. So remember to save and close this down. Again, if I go to my project, here I have several different projects, blah, blah, blah. I go into the one from now, and here we have a standard organization. So raw data with the raw data and how to clean it, data with the clean data, analysis folder with the different analysis scripts, and an output folder where it goes all the things we create. So now we don't only have a full data science project, we actually have a well-organized data science project. So yet another step on the way. Time to finish up. So what should you do? What should you know until next week? You should go through, create a project where you have data that you need to tidy up or clean. So pivot, like try the pivot longer, try the pivot wider, trying the pivot longer to create several columns, try to join data. So you have two different data sets that you join together. Go in, read the web page, read the vignettes or articles, read the help pages for the tidyr and the dplyr, maybe the readr if you want to go see more details there also. And one thing missing that I haven't showed you yet is the cheat sheets. So these are, once you've read about like once you have a little bit of an idea of a package and how it works and these things, several of them has what is called a cheat sheet, which is just a short version of, in 1 page or 2 pages, get an overview of the important functions and what they do. Couple of ways to access them. In RStudio's help menu, you have cheat sheets and you have several different ones. So we have here data transformation with dplyr. You can click there and go directly to the website with downloading a PDF with a cheat sheet. The other way is oftentimes on the web pages of several of these packages. So if we go to the tidyr web page, you scroll down and you see the cheat sheet here as well. So the cheat sheets, if we look at them, what they are is, again, you can download short forms of visualizing, present to, in a visual way, present what the different functions do. So here we say, let's open the tidyr. Okay, data tidying with tidyr. How does this work? Okay, we can, here it talks about tidy data a little bit in general, these things, so we can reshape data, pivot data, right? We have the pivot longer, pivot wider, with a little bit of help to visualize. Here is something to expand tables that we haven't looked at. So here's another set with some visual help. How do we split cells and unite cells? So here is the unite that we used. Remember, we had 2 columns, put them into 1 column. So here you can read through and get like a little bit shorter help, more to remember, not to learn maybe, but to remember things when you know kind of the functions, but are not completely sure. So check them out. When you read through the webs and vignettes and help, try new functions. Try functions that we haven't looked at. See if you manage to grasp them, get them to work, get them to function. And the last step, create a good folder structure for your project. So it doesn't have to be exactly like the one you showed, but think through, how would I want to organize these kind of projects into different folders? Some key concepts, this will come, is just what we talked about today. So you will get it in the PDF version of the presentation that Florian will upload early Monday. That was all for today. Next week, we'll look even more into importing different type of data and just finishing up the full project. And we'll talk a little bit more about the exam that you will make. So thank you all for today. And see you again next week or in my email with questions.